So a pretty tricky simultaneous equation here. We have a linear equation, which is the top one, the highest power of x or y is 1, and then we have the nonlinear equation underneath it. So the method for solving these is to take the linear equation and to express one of the variables in terms of the other one. So I'm going to say that 5x is equal to 2y plus 3, and then x would be equal to 2y plus 3 all over 5. So the fact that there's fractions in this question just makes it a little bit trickier. We're going to sub this value of x back into the nonlinear equation where we have the x's. So that nonlinear equation now becomes x squared, which we know is 2y plus 3 over 5, all to be squared, plus the y squared minus 2 times x, which again is 2y plus 3 over 5, and then we have y after that, and that's equal to 0. So we're going to do a little bit of tidying here. When we're squaring this bracket, we're going to square the top of the fraction, and then we're going to square the bottom of the fraction. Squaring the top of the fraction, we have 2y squared is 4y squared, 3 squared is plus 9, and then square the first, square the last, and then twice the product. So the product, if we multiply these two together, we get 6y, and then twice that is 12y. And then if we square the bottom, we get 25, plus the y squared. So the next little piece is a little tricky to multiply out. I'm going to multiply the minus 2 by the y, first of all, to give me minus 2y outside the brackets, and then I'm going to split the bracket as I multiply it. So I'm going to express each of the terms over 5. So what I get is I get minus 2y times 2y over 5, which is minus 4y squared over 5, and then minus 2y times 3 over 5, which is minus 6y over 5. And I just split them like that, just so I make sure I don't make any mistakes with the signs going forward. And then this is equal to 0. I want to get rid of the fractions in this question, so the easiest way to do that is to multiply every term in the equation, both on the left side and the right hand side, which is just 0, by the number 25. If I multiply the first fraction by 25, I'm left with 4y squared plus 12y plus 9. Multiply y squared by 25, I get 25y squared. And then if I multiply minus 4y squared by over 5 by 25, I get minus 20y squared, and then minus 6y over 5 times 25 is minus 30y. So what we're doing there when we multiply by the 25 is basically if I multiply both those terms by 25, 25 cancels with 5, and I'm really multiplying the numerator of each of those fractions by 5 instead. So 5 by minus 4y squared is minus 20y squared, and 5 by minus 6y is minus 30y. And I'm going to let all this equal to 0. An alternate way to do that is obviously to maybe put y squared over 1, find a common denominator, which it will be 25, and you'll get the very same line on the next part of the sum. Okay, so we're going to make a quadratic equation out of this. So I have 25y squared minus 20y squared is 5y squared, plus 4y squared is 9y squared. I have 12y minus 30y, which is minus 18y, and then I have the plus 9. So we can see when we form this quadratic, it's divisible by 9. So what we're going to do next is, just to make the factorization a little easier, we're going to divide across by 9. So when I do that, I get a quadratic that has y squared minus 2y plus 1 equals 0. And factorizing this, if we're not good at the factorizing, we can always use the minus b formula, but this is easy to factorize. We have a y and a y. Two numbers that multiply to give 1 are 1 and 1. And then we have a minus 2y in the center. So the product of the inner is y, and the product of the outer is y. And we need those to combine or sum to give minus 2y, so we need two minuses. We then let each bracket equal 0. So we have y minus 1 is equal to 0. And obviously the other bracket is the same, y minus 1 equals 0, which means that y is equal to 1. So we just get one solution for y in this. Sometimes when we're doing these questions, we would get two different or distinct solutions for y. We're going to get one solution here. So we're going to sub this value back into our linear equation. And we've already tidied the linear equation to give us x on its own. So x is equal to 2 times y plus 3 over 5. We now know that y is 1, so x is equal to 2 times 1 plus 3 over 5. X is equal to 2 plus 3 over 5. X is equal to 5 over 5. So x is also equal to 1. And so we have a solution set of x equals to 1 and y is equal to 1.